Morning children. The new lesson, laws of motion. Newton proposed 3 laws. First law, second law, third law. In this lesson, we are going to discuss about all these 3 laws which are proposed by Newton. First of all, we are going to discuss about the Newton's first law of motion. Children, you know that this is a book. If I will keep this book today and tomorrow I will come and once I check means the book is there only. Okay children? And if you are riding in a bicycle with a particular speed, when will you come to stop? If you can apply force on the brakes, or otherwise I will come to against to you and I will push some force against to you, then only you are comes to rest. That means every object is continuous in a state of rest or continues in a state of motion, uniform motion, unless some external force is acting on it. Okay children? Without any application of the force, this book is keeping like that only. If I will apply some force, then only the object will move. That means every object continues in a state of rest or in a state of uniform motion unless some external force is acting on it. This is the Newton's first law. Once again I will say that every object will remain at rest or in a state of uniform motion unless some external force acting on it. For example, let us consider a ball which is in the floor. The ball is at rest. How many forces are acting here? 2 forces. One is gravitational force, another one is normal force. Both forces are acting on the object in opposite direction. One is downwards, another one is upwards, and both are equal in magnitude. That's why the object will not move any direction. This is in the y-axis direction. When we are coming to the x-axis direction also, there are no net forces acting on it because applied force is not there. So the object seems to be at rest. How far the object is at rest? Until some force is acting on it. If I will apply some force, what is happening? Actually, the object comes into motion. If there is no frictional force acting on the ball is moving continuously until some external force is acting on it. But in this case, the ball is on the floor while I am applying some force. First of all, it can move with more speed. After covering distance, what happening? Its speed is gradually decreasing. After particular point, after covering some distance, it comes to rest. So according to Newton's law, when we apply some force on the object, it continues in a state of rest. But why it comes to stop? Because against to the applied force, what is acting? Some frictional force is acting. Because of that frictional force, the object, that is the ball, comes to rest. So from this example, we can conclude that every object continues in a state of rest or continues in a state of motion unless some external force acting on it. For that I will I will give one example for that. From this Newton's first law, we are getting one property That is nothing but of inertia. What is that inertia? Inertia is nothing but of not accepting change. So before going to discuss about that definition, we will discuss some examples given in this. Here, this is the bottle, and this bottle is covered with a cupboard, that means plastic piece of board, and in that one cap is there. If we can jerk that cardboard immediately from this bottle, means what happening? The cap will fall down. From this activity, what you can learn? The cap is at rest. Even though the cardboard is moving fastly, the cap is continuous in a state of rest. That's why it falls down in the bottle. Children, are you playing caroms? While you are playing caroms for rupees, not game, you can keep the coins in the board like this. While you can hit the coins with the striker, what happening? This coin will move, and the stack of means group of coins will be like that only, because when we hit this one, this is in the motion. But remaining coins will be in a state of rest. That means the coins are continuous in a state of rest, even though one of the coin is moving. And coming to that, traveling in a bus. Children, while you are standing in the bus, now it is ready to start. The engine starts by the driver. Immediately after moving the bus, you will move backwards, because even the bus is in the motion, you are trying to continue in a state of rest. That's why you will be moved backward. Okay, the bus is moving. If any obstacle comes opposite to you, immediately the bus driver will apply brakes. In that case, you will move forward, because the bus comes to rest, but our body is continuous in a state of motion. That's why you are move forward. That means every object continues in a state of rest or continues in a state of uniform motion unless some external force is acting on it. I'm coming to the football. Children, are you playing in the ground of football? You can keep the football. How far the football will be kept like it? Until someone kick the football. Someone applying force on that football, then only it will move. If we can hit the football, it is moving upward, means it is moving upward only. Actually, what happening? If we can apply some force on that object, it continues in a state of motion. But against to that football, some gravitational force is acting. That's why it will move down. And we can say Newton's first law of motion in another way. F net is 0. Here F net is 0 means, let us consider the object is at rest. Now only I said, how many forces are acting on that object if it is in the rest? Two forces. One is gravitational force, another one is normal force. What is the net force acting on that? Two forces are acting in opposite directions with equal magnitude, means the net force is 0. Applied force and friction force. If we can apply some force, friction force also apply. In that case also, F net is 0. So, F net is 0 means either the object is at rest or the object is in uniform motion. If an object is moving in uniform motion, in that case also, F net is 0. So, we have to say that if F net is 0 means either the object is at rest or uniform motion. That means we can say the object is in equilibrium. The object is in equilibrium. Okay, now we are going to discuss about that Newton's first law in the other form is inertia. Okay, children, you know that